Hi there! Welcome to our overview and demonstration of Passmark's Inline PSU Tester. In today's video, I'll be introducing you to our latest hardware product, running you through exactly what it has been designed to test, and showing you a demo of the PSU tester across its different usage configurations. A faulty or out-of-spec PSU can cause a range of symptoms: blue screens, sudden shutdowns, failure to power on, or system lockups. It is often hard to know which component is at fault, and diagnostics is often reduced to trial and error. Using the PSU tester, you can quickly confirm if the PSU is bad and what exactly might be bad, or eliminate the PSU as a suspect altogether. This can save technicians hours of time by avoiding random swapping of components and other time-consuming activities, like a Windows reinstall. So you might be thinking, why has Passmark developed the Inline PSU Tester when there are multiple other PSU testers already on the market? Well, in fact, we used to sell a comparable PSU tester, but we found that we were limited in the depth of testing and the results that we could gather. So, instead, we designed and built the most extensive and complete diagnostic utility for PC ATX power supply units on the market. With the Passmark Inline PSU Tester, you can check power supply voltages within the approved limits, record the minimum and maximum of voltage and current for each voltage rail, measure the exact power drawn from each voltage rail, measure the total power drawn from the power supply, test for ripple on main voltage rails, measure and check power on time, rise time, power OK delay, and power down warning, all against the specification. Measure the minimum slew rate on main voltage rails during power up. Check that the turn-on slope of main voltage rails is positive during power up. And check power sequencing is correct. So all these features might sound great, though perhaps they need a little bit more of an explanation. So let's take some time to understand a little bit more about exactly how a PSU supplies power to your PC. A power supply unit, or PSU, converts mains AC to low voltage regulated DC power rails for the internal components of a computer. The PSU normally supplies 3.3 volt, 5 volt, 12 volt, and negative 12 voltages to a PC. Older systems were designed to draw most power from the 5 volt and 3.3 volt rails, while newer machines draw most of their power from the 12 volt rail. The negative 12 volt supply is primarily used to provide the negative supply voltage for the RS-323 ports, but is also used by one pin on conventional PCI slots to provide a reference voltage for some models of sound cards. The PSU supplies power to your motherboard across 4 main cables. 1. The 24-pin or motherboard power cable, which is a 20 or 24-pin connector. This provides power to, you guessed it, the motherboard. If we take a look at this illustration of the 24-pin motherboard connector, you can see each of the pins and their respective signals. You might also note signals for power on and power good. These form part of the timings for when a PSU is powered on, and we will elaborate on their role later in this video. Secondly, we have the CPU power cable, which provides power to the CPU across 4 or 8 pins. Thirdly, we have the PCI Express power cable, which provides power to graphics cards across 6 or 8 pins. And lastly, we have the SATA power cable. SATA cables provide power to hard drives. The connector is shaped so that it can only be plugged in the correct way. However, as the connector on the PSU doesn't have the lip, it's important to ensure it's aligned properly. We will explain this later in the video, and this is significant to note as it could cause issues when testing if not aligned properly. These are the 4 major connectors that we test as part of our Inline PSU tester. So now that we understand how the PSU is providing power, how can we leverage testing for troubleshooting or diagnosis? At this point, we should also probably note that the Passmark Inline PSU Tester is testing power supplies against the ATX 12 volt standards. ATX, or Advanced Technology Extended, is a motherboard and power supply configuration specification developed by Intel in 1995. The specification defines key mechanical dimensions, mounting points, I/O panel, power and connector interfaces between a computer case, a motherboard, and a power supply. The ATX specification requires the power supply to produce three main outputs: 3.3 volt, 5 volt, and 12 volt. The low power negative 12 volt and the 5 volt standby supplies are also required. As of now, the latest version is ATX 12V, version 2.4, published in April of 2013. The Passmark Inline PSU Tester is designed to test things such as DC regulation range. As we understand, a regulated power supply converts AC power into constant DC. Its function is to supply a stable voltage within certain power supply limits. So, the PSU tester can measure the DC output voltages so that they shall remain within the regulation range of plus or minus 5%, except for the negative 12 volt, which has a tolerance of plus or minus 10%. Output ripple noise. Ripple, or specifically ripple voltage, in electronics is the residual periodic variation of the DC voltage within a power supply, which has been derived from an AC source. This ripple is due to incomplete suppression of the alternating waveform after rectification. So the PSU tester can measure the output ripple noise, testing to see if they remain under the max MVPP, or millivolts peak to peak. Timings. When we first turn on the power supply, voltages are not immediately available on the power supply outputs. They increase or ramp up until they reach their correct values. This increase happens in a fraction of a second, a maximum of 20 milliseconds to be exact. In order to prevent a computer from attempting to operate at these lower than normal voltages, the power supply has a signal called power good, or it's also called power OK, or simply PG, which tells the computer that the 12 volt, 5 volt, and 3.3 volt outputs are at their correct value, and thus can be used. And the power supply is ready to work in a continuous fashion. This signal is available through the pin 8 wire from the main power supply connector. There are 4 timings that the PSU tester is recording. 1. Power on time, or T1. The power on time is defined as the time from when the PS on is pulled low to when the 12 volt, 5 volt, and 3.3 volt outputs are within the regulation ranges. The power on time should be less than 500 milliseconds. 2. Rise time, or T2. The output voltages shall rise from 10% of nominal to within the regulation ranges, within 0.1 milliseconds to 20 milliseconds. 3. Power OK delay, or T3. Power OK is a power good signal. It should be asserted high by the power supply to indicate that 12 volt, 5 volt, and 3.3 volt outputs are above the under voltage thresholds. The power OK time should be asserted within 300 milliseconds to 500 milliseconds. 4. Power down warning, or T6. During power down, the power OK signal should be asserted low at least 1 millisecond before the 12 volt, 5 volt, and 3.3 volt outputs reach their under voltage thresholds. Ramp up or slew rate. There must be a smooth and continuous ramp of each DC output voltage from 10% to 90% of its final set point within the regulation band. The smooth turn-on requires that, during the 10% to 90% portion of the rise time, the slope of the turn-on waveform must be positive. The tester monitors the slope and reports a failure if it detects a negative slope. Power sequencing. The 12 volt and 5 volt output levels must always be equal or greater than the 3.3 volt output during power up and normal operation. The PSU tester checks the voltage sequencing and reports it as V sequence. The time between the 12 volt and 5 volt output reaching its minimum in regulation level and the 3.3 volt reaching its minimum in regulation level must be less than 20 milliseconds. The PSU tester checks the timing sequencing and reports it as T-sequence. Efficiency. 80+ is a voluntary certification program intended to promote efficient energy use in computer power supply units. It certifies products that have more than 80% energy efficiency at 20%, 50%, and 100% of rated load. Such PSUs waste 20% or less electric energy as heat at the specified loads, reducing electricity use compared to less efficient PSUs. You can test the efficiency of your PSU when using the tester in conjunction with a third-party mains power meter. To check your PSU's efficiency, divide the watts from your total power of the PSU by the watts supplied by the mains power meter. Multiply the result by 100 for the efficiency of your PSU. Looking at the image on the screen, you can see us measuring the mains power on the left and the total power from the PSU on the right with the tester. Using the simple equation, we can see that the PSU we tested is operating at 75% efficiency. Using the PSU tester, you can measure the power drawn on each rail and confirm it is within the specs of the PSU. Take a look at the attached example, because most PSUs come with a power table, which break down the rails, max load, and max output on the case. With the PSU tester, you can test and confirm each rail is within the specs of the PSU. So now that we understand how a PSU is supplying power and what our product is designed to be testing, how can we actually use this product? Well, the Inline PSU Tester features an LCD display designed to show voltage, current, ripple, and power for each voltage rail. This allows for quick testing without the need for inline or monitoring software. The display has been designed so that you can quickly and simply troubleshoot elements of your PSU. Screens can quickly show you the total power, which is the total power drawn by the tester or motherboard, voltages, which show pass when voltages are within the regulation ranges, timings, which show pass when all the timings are met. NA means that some of the timings are not yet measured. These are calculated during power up and power down processes, so that might mean that you need to cycle through once or twice to check back for timing calculations. The background color of pass and fail messages can be green, red, light red, and yellow, and each color has a different meaning. The green pass means voltages are currently within the approved limits and have never been outside the specifications. A light red pass means voltage is currently within the approved limits, but an overvoltage has been detected. A yellow pass means voltage is currently within the approved limits, but an undervoltage was detected. And fail means voltage is outside of the approved limits. The PSU tester also has a membrane keypad with 4 keys. The first is the power on or off button, which forces a power up by asserting the PS on pin to logic low. Please note this button shouldn't be used when the PSU tester is in inline configuration. Instead, the PC should be turned on or off using the standby button from the computer. We also have a page up and page down button, which are used to navigate between the different pages. And lastly, we have a mode button, which allows the user to change the mode of details on each page. Using this button, you can change the mode from voltage to current or power while on a voltage page, or you can see the timing values while in the timings page. The product also has input and output connectors. The tester has 4 inputs and 4 output terminals: 24-pin, CPU, PCIe, and SATA. The input terminals are marked with IN and should be connected to a PSU. The output terminals, which are only used in inline configuration, are marked with OUT and should be connected to a motherboard. We also include a range of cables with this product: a 24-pin connector for the motherboard, a CPU connector, a PCIe connector, a SATA connector, and a USB 2.0 A to B cable for connecting the tester to a PC for logging and monitoring. The Inline PSU tester can be used in 4 different modes across 2 configurations when testing a PSU. Let's take a look at these 2 main usage configurations now. We'll start off with standalone mode. In this configuration, the PSU tester is only connected to a PSU, meaning it isn't also connected to the motherboard. Use this configuration for product line testing or when a PC doesn't boot. So before you start off, for your safety, turn off the power supply using the 1-0 switch on the back panel and switch it to the 0 stand. Then disconnect all peripherals and devices from your power supply. Then connect your 24-pin, 8-pin and 6-pin cables to the PSU, corresponding with the in terminals of the PSU tester. Note that some power supplies have an 8-pin PCIe cable. In this case, detach the extra 2 pins and connect the 6-pin side. When connecting the SATA cable, align the bottom of the L-shaped connector with the bottom of the PSU tester. You can then plug your AC power cord back into the main. Then turn on the power supply by setting the 1-0 switch back to the 1 stand. Press and hold the power button on the PSU tester for 3 seconds until the display shows power on. Then using the up and down buttons, you can navigate between pages to check the voltage and timing. By pressing the mode button, you can also switch between voltage, current and power modes, or you can see the timing values. Secondly, we'll look at inline mode, and this is where the PSU tester is connected to the power supply and a motherboard. Please note that inline mode is always more likely to reveal the root cause of more complicated issues. It also results in the PSU being placed under a much higher load. Then connect your 24-pin, 8-pin and 6-pin cables to the PSU, corresponding with the in terminals of the PSU tester. Note that some power supplies have an 8-pin PCIe cable. In this case, detach the extra 2 pins and connect the 6-pin side. Now, use the PSU tester cables to connect the out terminals to the motherboard and PC peripherals, such as your hard drive and graphics card. Plug the AC power cord back into the main and turn on the power supply by setting the 1-0 switch back to the 1. Turn on the machine using the standby button from your computer case. Using the up or down buttons, you can navigate between pages to check voltages and timings. By using the mode button, you can switch between voltage, current and power modes or check the timing values. If the monitoring port is connected, you can run the monitoring software and check the PSU parameters from the software as well. Also note, you can run burn-in tests during inline testing to ramp up power usage by the motherboard and place more load on a PSU. It is important to note that the max load we can measure in inline mode is roughly 1600 watts. Take a look at the ratings provided on the screen for a 1600 watt PSU. Higher capacity PSUs can also be connected to the tester, provided that the current drawn from voltage rails do not exceed the maximum allowed current mentioned in the above table. It's also worth noting that the PSU tester can be connected to a computer via USB and monitored with the monitoring software in both standalone and inline mode. To use the included monitoring software, connect the PSU tester to your PC via the USB connection. While using this software, you can monitor the PSU statistics, including voltage, current, power, ripple, and timing for each voltage rail. To connect the device, use the COM port. The PSU tester appears as a virtual COM port when connected to your PC. To understand the PSU statistics, look at the section that displays voltage, current, power, and ripple, plus timings for each voltage rail. A green background for a field means the value is within the acceptable range, and a red background means the value is outside the valid range. A grey background indicates the measurement has not yet been completed, so 1 or 2 power cycles is required for the value to be calculated. NA simply means the measurement is unavailable. Our monitoring software has multiple control buttons. The first is a power on and off. This button forces the PSU to power up or down. However, do not use this button when the tester is in inline configuration. Instead, use the standby button from your computer case. We also have a clear log button. The monitoring software records all voltages in the system memory at intervals set in the configuration window. This button can be used to erase all the previous records. We also have a save log button, and when using this, you can save the log into a comma-separated value format CSV file. You can reset min or max. This button resets the minimum and maximum values for voltages and currents. We have a Save Report button, and using this button you can save all the PSU statistics in a text file. We also have a configuration window. The following options appear in this window. Connected cables. This allows you to specify which cables are connected so that the unavailable voltages will be excluded from the pass-fail criteria. We also have a compliance mode, and this option allows the user to select a level of compliance. In the strict mode, all voltages and timings are checked against the specification, and any out-of-range value in any of the measured values will lead to a fail. In the loose mode, the criteria for a pass will be loosened to allow an easier pass when most important values are within the range. Take a look at the table on the screen, which summarizes the criteria for the loose mode. We also have a buzzer mode, and this allows the user to specify a condition at which the buzzer should alarm. Take a look at the table on the screen, which summarizes the different modes. We have fatal errors, which makes a sound when voltages are outside the specification or a power OK signal is not asserted by the PSU. We have compliance, and the buzzer makes a sound when the voltages or timings are outside of their approved limits. And we have an off mode, where the buzzer is always off. We also have an option to specify log intervals. This allows us to specify the time intervals for samples in the log file, and all data can be exported to a text file report. If you have a machine that has more than one CPU or GPU, not to fear. At this point in time, we have accommodated for systems with up to 2 CPUs and 3 GPUs. As the PSU tester only has one connection for each of these rails, we have proposed 2 solutions. 1. Test one CPU or GPU at a time and complete a simple addition to acquire the total power. Or 2. Use multiple testers in inline mode, where all rails can be monitored from one instance of the software. So what is the process for testing these machines? Firstly, ensure that your firmware and software are up to date. These can be found on the Inline PSU Tester download page. Connect your PSU tester to the corresponding in terminals and relevant connectors to your motherboard, as you would under normal testing circumstances. This tester will become your primary device. If the motherboard has 2 CPU or GPU power connectors, connect a spare cable to corresponding in terminals of the second PSU tester. If the PC has a third GPU, connect a spare cable to the PSU corresponding in terminals of the third PSU tester. It is important to note that the motherboard connector provides a reference ground for voltage readings. As you can see in this picture, the 6 and 2 are split on the 2-pin side, and it is connected to column number 6. This provides the ground reference. Now that all the PSUs are connected to the motherboard, use the included USB cables to connect it to your PC. Start the monitoring software and select your master device. Each tester has a unique serial number which will be displayed upon connection to the USB port. Then connect your secondary and tertiary testers. Once these are connected, you should be able to see the additional inputs from the secondary devices at the bottom of your PSU test display. Please note, if the motherboard has only one CPU connector, disable the second CPU cable from the configuration page to avoid reporting a failure for that voltage rail. Similarly, if the motherboard has 2 CPU connectors and no additional GPU, disable the second GPU cable from the configuration page to avoid reporting a failure. For more information, visit Passmark.com and look for the Inline PSU Tester in our products today. Safety is of utmost importance, so please ensure you use our Inline PSU Tester according to our safety guidelines. Before using your Inline PSU Tester, remove anything that could be conductive from your hands. Items such as jewelry and metal rings, bracelets and watches are most notable to remove. Only ever use the original cables that were supplied with the tester. These cables are not standard, and the use of different cables could result in a short circuit between the voltage rails. Always make sure that the cables are fully inserted before using the Inline PSU Tester. A loose connection causes an increased electrical resistance, which could result in damage to the wires or, in worst cases, even a fire. In the case of a dramatic failure of the device under a test, if you see smoke or smell burning, unplug the power supply from the wall immediately. During such an event, do not touch the PSU or PSU tester. Always monitor the testing in case the device being tested suddenly fails. This means remaining present, so do not start a test and walk away. If the PSU tester is being used inline, connected to both the power supply and the motherboard, do not power up using the keypad on your PSU tester. Instead, use the PC power button. This is a precaution to prevent a short circuit on the PS online. In standalone mode, the tester will dissipate 4 watts of power in order to place a test load on the PSU. This can result in the base of the test unit becoming warm. This means the tester will terminate after 1 minute to avoid overheating. When connecting your cables to the PSU to test an inline configuration, ensure that none of the wires are obstructing the CPU or graphics fan. This could cause the CPU or graphics cards to overheat. For more information, visit Passmark.com and look for the Inline PSU Tester in our products today.